Good morning, students. Students, this lesson is of class 8th for the subject of physics. Chapter 3, Laws of Motion, which is given on page number 56 of your physics textbook titled Concise Physics by Selena Publications. Children, in the first exercise, we will be learning about effect of force and different kinds of forces. Children, as you all must be knowing that any push or pull acting on an object is known as force. So what is force? Any push or pull acting on an object is known as force. Now let us learn the effect produced by the force exerted. So firstly, a force can change the state of rest or of motion of the body. That is, it can produce motion in the body. Children, a force can change the state of rest. That means when the body doesn't move. Or if the body is already in motion, by applying force, you can stop the body. So children, if you apply a force to kick a ball at rest, then the football comes in motion. You must have tried it. If you kick the football, which was already at rest, by kicking the ball, you are applying force, and due to which the football comes in motion. Similarly, a fielder on the ground stops a moving ball by applying force with his hands. And children, the second effect of the force is it can change the size or shape of the body. That is, it can change the dimensions of the body. For example, on pressing a piece of rubber or clay, its shape changes. Children, in your younger age, you must have made many different objects using clay. So what are you doing then? You are applying force on the clay to change the size or shape of that clay. Similarly, in a cycle pump, when the piston is lowered, the air is compressed to occupy a smaller volume. Now, children, we will study what is the effect of force applied on rigid object and on non-rigid objects. Firstly, let us see what happens when force is applied on rigid object. Children, when force is applied on a rigid object, the force applied does not change the interspacing between the constituent particles. That means that if you are having a rigid object, there are certain particles in between the rigid object. So when you are applying force on the rigid object, the distance between the particles, interspacing means the distance between the particles remains same. It does not changes. So the interspacing does not change. It means that you are not able to change the shape of a body. So when interspacing is not changing, it means that the force applied does not change the dimensions of the object. But when you apply force on such an object, then what happens? You can bring the object in motion. Children, for example, in your car, if you push the car, if some people, around 2-3 people, starts pushing the car, the spacing between the different parts of the car doesn't increase. Rather, you can set the car in motion. It can start moving a little bit with a very, yes, small speed, but yes, it can start moving. Now, what happens in case of a non-rigid object? Children, when a force is applied on a non-rigid object, the force applied changes the interspacing between the particles, and thus it causes a change in its dimensions. So, if you apply force on non-rigid object, two things can occur. Firstly, you can change the dimension of the object, and secondly, you can also produce motion in the object. While in case of rigid object, only motion can be created. So children, let us understand what is force. We have to learn the definition of force. So what is force? A force is that physical cause which changes or tends to change. So which changes or tends to change either the size or the shape or the state of rest or of motion of a body. So what can force do? Either it can change the size or the shape of the body, or it can bring the object in motion, or it can stop the moving object. So this is the effect of force. Now children, in this class, we will also study different types of forces. Forces can be classified into two types. One is contact forces and the other is non-contact forces. Now children, first of all, we will study about contact forces. So, as its name suggests, the forces which are applied on bodies by making a physical contact with them are called contact forces. These forces are produced and experienced when a body comes in contact with another body. If you want to experience a contact force, there should be a physical contact between the two bodies. So there are many forces which comes in this category. So let us learn one by one. First comes the frictional force. When a body slides over a rough surface or rolls over a rough surface, so a force starts acting on the body along the surface in contact. So this is called frictional force. So what is a frictional force? When a body moves on a rough surface. Suppose the surface is rough, and if a body is rolling on it, or if it is moving on it or sliding on it, then if the body is moving in a forward direction, children, the frictional force acts opposite to the motion. If the motion is forward, then frictional forces will be backward. So this is the direction of frictional force, and it will always act in the direction opposite to the motion of the body. And see where it is acting. It is acting when the two objects are, the surface and the circular object are in contact. If the object was not in contact with the surface, then what would have happened? Then if this surface is not in contact with the object, then there must not have been frictional force. So friction will be acting only if the object is in contact with the surface. Very good. So let us move to the other type. That is normal reaction force. Children, when a body is placed on a surface, the body exerts a force downwards, which is also known as weight of the body. So when you place a box or a book on a table, the weight of the body is exerted on the surface. in this direction. And the surface will also exert a certain force on the object in an upward direction. So the surface, in this case, the table is acting force on the box in an upward direction. Now this force which is acting above on the box here, in this case, it is perpendicular to the surface. See, these two forces are perpendicular to the surface. So this case, this is perpendicular to the surface. Perpendicular in physics can also be said as normal. So normal means perpendicular. So this force which is acting perpendicular to the surface and is equal to weight of the body is known as normal reaction. Children, this is the reaction force given by the surface. What is it? It is reaction force given by the surface, and since it is acting perpendicularly, thus it is also known as normal reaction. What is it? Normal reaction. So what is normal reaction? A force which is exerted by the surface, normal to the surface, and is equal to weight of the body. So normal reaction will also occur when the body is in contact with the surface. So children, when a body is placed on a surface, the body exerts a force downward. The body, suppose this is the body, box is the body, it is exerting a force downward, and that force is equal to its weight. But is this box going down? Is it moving downward? No, the answer is no. Why? Because the surface exerts an equal force in an opposite direction. So we can say the surface, in this case, the surface is table. So the surface exerts an equal and opposite force on the body, normal to the surface, and this force is known as normal reaction. The word normal means, right now I told you, normal means perpendicular. Thus, it means that normal reaction means that reaction forces perpendicular to the surface on which the body is placed. Children, next comes the force due to tension, which is also known as tension force. Now, when the body is suspended by a string attached to a rigid support, the body, due to its weight, pulls the string vertically downwards, and the string in its stretched condition pulls the body in an upward direction. By a force which balances the weight of the body, the force developed in the string is called tension. So children, what happens here? The weight of a body pulls it downward. So due to which there is a certain force acting in an upward direction in the string. This upward force is known as tension in the string. Tension. Tension will be always there. It will be always present in the string or a thread or a rope which is suspended by a rigid object. So see the direction of tension. It is vertically upward while weight is acting downward. So this is a force due to tension. Now comes the next force, that is force exerted by a spring. Now children, if one end of the spring is kept fixed, suppose we keep one end of the string fixed and the other end is free to move. So if you pull the other end, you can either stretch the spring or you can compress the spring as shown to you in the diagrams also. The first diagram shows you the stretching of the spring. If you pull the spring towards yourself, you can expand the spring, which can be known as stretching a spring. Similarly, when you push, you apply the force and you push the spring inward, then what is happening? You are compressing the spring. Children, when you compress the spring or when you pull the spring, when you stretch the spring, the shape of the spring changes. And when you stop applying force, what happens then? The spring returns back to its original direction. So if you're pulling it outward, when you stop pulling, there is a restoring force which will bring the spring towards its normal shape. And restoring force means a force which changes the deforming produced by you when you applied force. When you are pushing it, the spring is compressed. So when you leave, when you don't compress it further, and when you don't apply the force, the restoring force acts outward such that the spring comes in its normal shape. So this is the force due to a spring. So see here in the next figure also, I have shown you stretched spring and compressed spring. So what is happening in expansion and compression? The restoring force is acting inward so that the spring can come towards original shape in case of expansion, while in case of compression, the restoring force is acting outward so that the spring can come in its original shape. Further, we are having a force exerted due to collision. Now, what is collision? Children, when two bodies collide with each other, they push each other. As a result, equal and opposite forces acts on each body. Thus, these forces are the forces of action and force of reaction. It happens sometimes that if you strike an object with the other object, then what happens? Both objects will apply opposite forces to each other. The same happens when there is a collision between two vehicles. The same will happen here also. So children, when two bodies collides with each other, or you can say when two bodies move towards each other, then they will collide with each other due to force exerted by the bodies on each other. So with this, I come to an end to this interactive session. You all are required to go through the PDF notes and learn the different types of contact forces. In this PDF, we have discussed only about contact forces, and we will do non-contact forces in our next class. So thank you, students, and have a nice day.